This is our final lesson in the unit of logarithm, 5.6 part 3. And our goal is to use the change of base formula to determine the value of a log and sketch a transformation graph of a log function. Your assessment is to complete lesson 2, sketching logarithmic functions, in your example booklet 5. Just to remind you the key concepts, the change of base formula can be used to evaluate a log with base other than 10, and transformation can be applied to the graph of a logarithmic function using strategies we have established earlier. And we've been using throughout this lesson the change of base of a log. And for transformation, we're using the transformation function. And we said a general transformation is xy. You have a log function, find the log function of xy correspond to the transformation x over d plus h for the x value, and the y value would be cy plus k. So we look at a couple of examples, and this will wrap up lesson 5.6. This is from your assignment in your textbook. Here we have a graph y. Yes, the graph y equals negative 1/4 log 2 half x plus 1. Now, this will be a C here, look like a D. Now, this is a general transformation formula for logs. And just to remind you, what C refers to the vertical stretch, the D, the horizontal stretch, factor of 1 over D. The H refers to the horizontal translation, and the K, vertical translation. We said if D is negative, then we have a reflection, and C is negative, we have a reflection. The first thing you want to do whenever you give it a transformation, a log function to transform, we look at the base log. In this case, if you were to strip off the transformation here, remove quarter, remove the half, remove the 1, we're left with y is equal to log 2x. And this is a transform, so we can write it down here. We can say log 2x, and we want to transform it into this here. So the easiest way to approach this is to create a table of values for y is equal to log 2x, and then use the values for the y coordinates and the x coordinates for this, and substitute it into the transformed log function. So let's look at our here. 1/4 tells us that we have a reflection. We have a reflection of a quarter along the x-axis. So C refers to reflection. We have a reflection on the x-axis here. But also, we have a vertical stretch. Right? In this case, it would be a compression of a quarter. So we have a vertical compression of a quarter. So our C value, if you can write that down here. So our C value here would be negative 1/4. And in this case, we have our DE as a half, and our k as 1. So here we have k is 1, the h is 0, our d is a half, and our c is negative 1/4. So let's look, so let's write it down here for a moment here. So from that, we have our k. We can start from our c first. So we have a c is equal to negative 1/4. This is your c here. You can write it down here. I'm matching here negative 1/4 log 2, and we have a half x. I'll just put here 0, so it tells me plus 1. So now I'm going to have my c. Then I have d, which is the next one we're going on to, is a half. So d is a half. H is 0. There's nothing here, right? So this is my h. And finally, k is 1. So if we place d with a half in our transformation, c negative 1/4 and k1, h0, we'll end up with, let's say we transform this. I wrote it down here already, but let's show you how I got this. So we have x over d, right? Now x over d is x over half, right? Plus 0. Okay, that'll be my, and c is negative 1/4 here. Y plus 1, because k is 1. If I were to simplify this now, it becomes 2x, and you have negative 1/4 y plus 1. Now that's why I got that. Okay, so I'm using this, and this is my transformation from here. These are my values substituted into it, and that's, so now to work this out, the next step now, here I have my log y, so y equal to 2x. Write this as an exponential. So if you write this as exponential, it becomes x equal to 2y. Remember, is 2 to the y equal x, number 2 to the exponent. Okay, so now we have our, I selected y values. Now I'm going to find my x value. So how we have 2 to the negative 1, that will give me 1/4. Then I have 2 to the negative 2, so 2 to the negative 1 will give me 1/2. So this is my x, and 2 to the 0 is 1. 2 to the 1 is be 2, and 2 to the 2 would be 4. So these are my x and y values. I'll use these x and y values to find my transformed x and y coordinates. So 2 times x would be 2 times 1/4. So it'll give me 0.5. If I would write that here, 1/4 multiplied. I wouldn't have enough space here. Well, this is 1/4 multiplied by 2. That gives me half. Then 2 times 1/2 will give me 1. 2 times 1 is 2. 2 times 2 is 4. And 2 times 4 is 8. And I use my x values here. I have negative 2, so negative 2 times 1/4 plus 1 So see what I mean by that. I have -2 because my y value here, a quarter times -2 plus 1. So this would give me 1.5. This is 0.5 here. So equals. Then I have -1/4 times -1 will give me positive. There you go. -1/4. Now plus 1 will give me 1.25. So this is 0.25 plus 1. So we have this will be 1.25. Then we have 0 plus 1 will give us 1. And you have 1 times -1/4 will give us plus 1 will give us 0.75. And 2 times -1/4 plus 1 will give us 0.5. So these are our transform points. So we have a half, 1.5, 1, 1.25, 2, 1, 4, 0.75, 8.5. Plot those points, and remember we said it's a reflection. So this graph will be should be going downwards. Let's see if it happens, right? So we have a half, 1.5. Oops, just a little bit. So x is a half, 1.5 is here. X is 1, y is 1.25. X is 2, y is 1. X is 4.75. This graph is going downwards. So we have our, so now we should have no y-intercept, by the way, because this isn't, because there's no horizontal translation, so we are asymptote here going to be x equals 0. We can conclude now our domain x is greater than, that's great, x is greater than 0, range, y, set of real numbers, equation of the asymptote, x equals 0. As you can see from here, you can predict the graph. We have a negative, so it's a reflection. And here we have, in this case, a stretch. We have a horizontal stretch. Right. And since there's no horizontal translation, our asymptote x equals 0. So there's no y-intercept. You could actually find the x-intercept by letting x be 0 and solve for y. Now let's look at one other question. And which is question 12. This is question 12 in your textbook. So graph the function negative 1/3 log 3. The reason why I would like to cover this question because it is a variation from most of the other questions. So you have to be careful with this question because here you need to factor out, in this case here, the -2 to simplify it. And secondly, we repeat our process as before. We find the table of values for log 3 to the x. So we have, if we remove the transformation, we have y is equal to log 3x. So we'll find the table of values and we change it to an exponential form, which will give us 3 to the y will be equal to x. So we'll select table of values for y, and I'll show you what I did here. And identify the intercepts of the equation as into a domain and range of the function. So recall this is our transform, general transformation. So this will be my table of values for y is equal to log 3x. And this will give me my transformation, negative. So first of all, simplify this and factor out the 2. And what we will have, we'll have -1 y is equal to log 3. Now -2 x. Factor out -2, this will give me +2 here. Maybe put a square bracket here. Then we have a vertical translation of 5. So if we were to compare it with this graph here, we have k. Actually, we have k. Oops, I forgot my k here. So k is 5. So we have a vertical translation, 5 units up. Then we have a horizontal translation of -2. So we have h is -2. Be careful, we change the sign there. Then we have c. Okay, let's go this way. First of all, d. Now d would be -2 here. C will be -1/3. If now we substitute our values of k in here, etc., we end up with the x is -1/2, -2, and y for the transform would be, the y coordinate would be 1/3 y, or -1/3 y plus 5. So we substitute it in here. So for example, here we go, x gives x over d would be x over -2. So whatever I have here, so let's translate to 1/2x. And h is -2, that's why I end up in -2 here. C is 1/3, -1/3, y plus 5. So now we have established our x and y general transformation. Find the coordinate values for the x values for x, sorry, y equal log of x. We already have the y value here. We have y is -2, 1, 0, 1, and 2. Work this out now. X So x is 3 to the power y. 3 to the negative 2 will give us 1/9. So we have 3 negative 2 is equal to 1/9. So 3 to the negative 1 is 1/3. 3 to the 0 is 1. 3 to the 1 is 3. And 3 squared is equal to 9. So these are our points for our, we're not going to plot it, but if you were to plot y equal 3x, those are your values. But we are going to use these values to create a table of values for a transformation. So when x is 1/9, so we have 1/9 times negative 1/2. So what would that be? 1/9 multiplied by negative 1/2 minus 2. Now what would that give us? That would give us, see here, negative 1 over 18 minus 2. So that would give us a 37 over 18 negative. So negative 37 for 18. It's kind of an interesting fraction. You could use your calculator and get the same result. So I'm going to use my calculator to give me my decimal. It's just under 1. Let's see what that gives us here. So negative 37 divided by 18. So that'll give me roughly 2.05. Our next one would be, so this will be mostly rational numbers. So I don't think there's any whole number here. So we have 1/3 times 1/2 will give me negative 13 over 6. This would be 1 times will give me negative 5/2. We have 3 times every 3. Negative 3 over 2 minus 2 would give us negative 7/2. And 9 times 1/2 minus 2 would give us 13/2. I'll change these to simplified numbers. So we have 2.05. So we have negative 13 divided by 6 will give me 2 approximately negative 2.7. So negative 5 divided by 2, negative 2.5. Negative 7 divided by 2, negative 3.5. And negative 13 divided by 2 will give me negative 6.5. So this will be my, well, this should be negative here. Then we look at our y. We have negative 2 times 1/3 will give us positive 2/3 plus 5 will give me 17/3. So what that be? 17 divided by 3 gives me 5.6. And the next one will be 16/3. Gives me 5.3. Next one will be 5. Get a whole number here. Because 0 times 1/3 is 0 plus 5. Then we have 1, and they give us about 14 divided by 3. Give us 4.66, 4.7 approximately. And then we have 2, give us 13 divided by 3, give us 4.3. So those are our points, and we plot them on the graph here. Now, let's look at our graph again. So where will be our asymptote? If you look back at our graph, our vertical asymptote will be at -2. So remember, you have a horizontal shift of 2 to the left. Okay, so we go back to our graph here. We shift 1, 2. So now instead of our standard y equal log 3 of x graph, this would be the asymptote. It's shifted 2 to the left. So this will be our vertical asymptote here. So x equal -2 vertical asymptote. So we established that. Now we go to our points. So -2.05, 5.7, 2.05, 5.7, which would be around here. -2.17, slightly up here, goes to 5.3. And we have 5, 2.5 would be about here. Then we have -3.5, which is here, goes to 4.7. -6.5, -4.3. So this is my graph. Y is equal to negative. Now, theoretically, you could have an x-intercept. So let's look at, okay, we have our horizontal asymptote. Sorry, vertical asymptote. So we have vertical asymptote. Move this here. So 1 vertical asymptote x equal -2. The domain of the function x has to be less than domain -2. Range would be y set of real numbers. Now they ask you identify the intercepts. The x-intercepts, say here, because we haven't found the x-intercept. We know that there's no y-intercept. So to find the x-intercept, we let we let y be 0 and solve for x, right? So solve for y is equal to negative 1/3 log 3 negative 2x. So let y equals 0 and solve for x. So we have here, so this is our equation, so we will rewrite it here. So we have y is equal to negative 1/3 so y is 0, we have negative then I put negative 5 over the line, so you have negative 5. Negative 1/3 log 3. Then we'll write this, remember, we'll write this now in exponential form. So if you write this in exponential form, what we'll end up, we have this is our, this becomes negative 1/3. We'd have here negative 2x minus 4 is equal to 3/15. So we have negative 2x is equal to, well, this huge number here. Plus 4. So x of the work this all out. So 3 to the 15 plus 4, negative 2. Do your wonderful calculation and answer the negative 7. Oh my, it's a huge number, Negative. Huh. Looking at my calculator here. Oops. 174,455.5. Now, it's a long way to go for your x-intercept. So this is our x-intercept. So this concludes lesson 5.6. And so your task is to complete lesson 2, assignment questions in booklet number 5.